Hi everybody, today's topic is called limiting reagent. Why is that important? Well, everything that we have done so far in these stoichiometry ideas has assumed that we have exactly the right amount of everything that we need, and everything is perfect, and everything is perfectly theoretical, and it all works great every single time. But in reality, we always know that we don't necessarily have the correct amount of everything at the correct the correct time. So what we're going to end up with is situations where we have a certain amount, but we can't necessarily use it because we don't have enough of the other substance. So let's do a real world example here to start off with. So remember, in all of these types of things, I'm going to start you off in the real world, and then we're going to come down here and we're going to get into mole world, right? So normally I give you one, and then I ask you about the other one over there. So, but if we have, according to this problem, let's say that some silly person decided to come up with 4,000 pounds of frames and 4,000 pounds of tires. That's there, and they want to go ahead and they want to make cars. Well, hopefully right off the bat you realize just how silly of a process this is, because we're going to have way too many tires and not nearly enough frames to go on those. Why? Because we know that a frame is about 2,000 pounds. So one frame is about 2,000 pounds here. So in reality, I only have two frames. And each tire is only 50 pounds, and so consequently, if I have 4,000 pounds at 50 pounds of tire, I have 80 tires. So I have two frames, and I have 80 tires. It's pretty obvious that I don't have the right proportion of things, because I need 4 times as many tires as I have frames over here, right? But I have 40 times as many tires as I have frames. So I have way too many tires. So in order to do this, what I'm going to do is I'm going to split now our moles into 3 different categories. The first category is what we have. Just because you have it doesn't necessarily mean you're going to get to use it. The use is going to be the next one. And that is by far the most important, because the used is what actually happens in reality. And then finally, I'm going to have leftover. So just because I have it doesn't mean I get to use it. In other words, one of these things is going to run out first. Or in other words, that is my limiting reagent. My limiting reagent is whichever one I run out of first. Okay? So, what's going to happen here? Well, I think it's pretty obvious that our limiting reagent is going to be our frames here. We have way too many tires, right? So if that's the case, let's just double check that to make sure that the math on that works out. So let's try to use all 2 of my tires, or my frames I should say, sorry. And then I'll be left with no frames, because I started with 2, I used the 2, and then I'm left with 0 that's there. Now if that's the case, then my used line is where I'm going to do all of my stoichiometry left to right, like I've taught you in the previous videos. So in other words, it's the used line that's going to go over here by a apparently 4-to-1 ratio, because I multiply by where I'm going, divide by where I came from. And so 4 times 2 is 8 that's there, so I'm going to use 8 of my tires. So if I start with 80 and I use 8, then I'm going to have 72 tires left over. Or I'm going to end up with 72 at 50 is 3,600 pounds of tires that are left over, because I couldn't use all of those tires. I could only use 8 tires, right? And then, by the way, if we were so interested, we could obviously figure out, going over here to cars, that it's going to be a 1/4 ratio, so I can make 2 cars, or I could have gone from over here to here for a 1-to-1 ratio. Doesn't matter which one that I pick. So as long as you are using the correct used line that is there. So the thing about limiting reagent is you're going to be given something here in the real world. You are then going to have to change that to the moles that you have, but just because it is the moles that you have doesn't necessarily mean that you get to use those amount. You're going to have to work through and figure that out. Now, let's just say that you're having a brain cramp kind of a day and you guess wrong. Even in a case like this that is so obvious, right? Well, let's see what would happen if you had chosen the incorrect limiting reagent. Or in other words, let's try to use up all 80 tires. All right, so I'm going to try to use all 80 tires to be left with none of them. Now I have to check to make sure that my other reagent, my frames, can handle all 80 tires. So what am I going to do? I'm going to go over here. By what ratio? Well, by a 1:4 ratio because of my balanced equation. So 1/4 of 80 is 20. So I have 2. I'm going to use 20, so I would be left with negative 18. Wrong. No. Wrong. Wrong. That just doesn't work. So if you get in a situation where you have chosen the wrong limiting reagent, and you check it against the other reagent that you have, you will end up with a negative number, and that can't be. You can't use more than you have, so consequently, you're going to end up with something that's wrong. So if you have chosen one to be your limiting reagent, you can always figure if you chose wisely by determining how much of the other one you're going to use. If you end up with a negative number, you chose poorly. If you end up with a fine number, then you've chosen wisely. Let's do some chemistry examples of this. All right, so here's a silly person that saw the 3-to-1 ratio here to here and said, you know what, then I need 3 times as much hydrogen. So if I have 250 grams of this, then I'm going to need 750 grams of this. Their heart's in the right place, but it's going to turn out that they have made some really terrible decisions here. So again, this is the real world that's there. Now let's go ahead and get into my mole world. And if I have my mole world down here, then I'm going to have 3 rows. Have, used, and left over. So my first is my have. I have grams of each, so I got to get these guys into grams. This stuff here is 1 mole per 28 grams, and so I'm going to have about 8.93 moles here that I actually have. Hydrogen here weighs 1 mole is 2 grams. That's there. But Smith, shouldn't I take this 3 into account and call it 6? No. I mean, you can, but again, you're really going to mess with the system if you do that, and I highly recommend you do not do that. We'll take that 3 into account in our used line, but we're not going to deal with it now. Because if I have 750 grams of hydrogen, then I know at 2 grams that's going to be 375 moles of the H2. Regardless of what balanced equation it is in, 750 grams of hydrogen is 375 moles. So again, if I knew that this was 750 grams of H2, it's going to be 375 moles of H2 regardless of what equation it happens to be operating in, which is why I don't like doing it that way. All right, so I think it's pretty obvious which one is our limiting reagent. Our limiting reagent is which one we're going to run out of first, and I think it's pretty clear that I have way too much hydrogen, that this guy here is going to be my LR, my limiting reagent. I'm going to run out of all of the nitrogen first. So let's see if that works. I'm going to try to use up all 8.93 moles to be left with none. If that's the case, then I'm going to come over here, and here's where my 3-to-1 ratio is going to be taken into account. So it's 893, so that's going to be about 26.79 moles that I'm actually going to use. So I'm going to be left over with about 348 moles here that are left over when I'm all said and done. Now, the question is asking how many grams of ammonia can be made. So if I want to know grams here, all I have to do is either pick the 893 or the 2679, because again, the used line is the one that's important. The used line is important. That's the one that you're going to be able to use left and right from. So from the nitrogen over to the ammonia, so from here 1 to here 2, I could do a 2-to-1 ratio, or if I'd prefer, I can go from here over to there. It's just going to be a 2/3 ratio. So either I take 2 of the 893, or I take 2/3 of the 2679. Either way I do it, I'm going to end up with about 17.86 moles that are over here. And then I can come up to here by knowing that that stuff weighs 17 grams per mole. So I'm going to end up with about 304 grams over here that I actually made. By the way, I have 348 moles that are left over. 348 moles at 2 grams a mole is 696 grams that are left over. The 696 and the 304 give me the 1,000 grams that I started with. So again, the law of conservation of matter is still in effect here. I haven't gained or lost any matter. It's just that I've only gained a certain amount of my product, and the rest of it just hasn't even been used. It's just been left over. So what you're going to do is you are going to establish how much you have, and then you're going to pick one, whichever one you think is best, to check to see if you are correct that that one is going to be your limiting reagent. Let's try another one here. All right, how many grams of hydrogen fluoride, so again, I want to know grams here, could be made if I have 4 grams of this and 14 grams of this. So this is my real world, but I really got to operate in the mole world. But since I have 2 of them, I'm going to have, I'm going to have use, and I'm going to have leftover. All right, so the first thing I'm going to do is change these guys into moles. That stuff weighs 17. 17 grams is equal to a mole. So 4/17 is about 0.235 moles here. And then this stuff here weighs 38 grams for a mole. So 14 out of 38 gets me about 0.368 moles that I have. Now, in this case, you look at it and you say to yourself, ooh, which one of these am I going to run out of first? Because both of those numbers are pretty close to each other, and they're both fairly reasonable, right? Now, you might look at it and say, okay, it's a 2-to-5 ratio, so clearly I'm going to need more fluorine. Do I have 5 halves as much fluorine? You know what? I can't do that math in my head, so I'm just going to guess. I'm going to guess, and I'm going to guess that I'm going to run out of the ammonia first. Let's see if I'm right. So I'm going to try to use up all 235 here and be left with none. Now, if that's the case, then I'm going to have to multiply that by a 5 halves ratio. So 0.235 at 5 halves gets me 0.588. And so we can see that I have guessed wrong. This is not the limiting reagent. Nope, I guessed wrong. Because I only have 368 and I'm trying to use the 588. If I subtract those out, I'm going to end up with a negative number, so I chose wrong. So even if you choose wrong, you can figure out the correct limiting reagent. It's just that now I got to go back and I got to do it again. No big deal, it doesn't take that long. It's just that in doing so, I now have to recognize that in reality, this is my limiting reagent. I'm going to run out of that guy first. Now let's prove it. I'm going to use all 368 here to be left with none. And now I'm going to come over here by a 2/5 ratio. A 2/5 ratio, so 0.368 at 2/5 gets me 147. So I know that I did things correctly. So 235 minus the 147 is going to get me left over about 0.088 moles that are left over, which is why, again, this guy is my limiting reagent that's there. Now, none of this answers my question. My question is I want grams of this guy up here, right? So if that's the case, then I got to get over to moles to him. Which one do I pick? It doesn't matter as long as you pick the used line and then do the proper mole ratio. So if I went from here all the way over to there, then my ratio would be 6/2 because I'm going to 6 and I'm coming from 2. If I choose this one to be my number, no problem. It's just going to be 6/5 because I'm going to 6, but I'm coming from 5. So either way you do it, 368 at 6/5 is 0.442, or the 147 at 6/2, which should be 3-to-1, is basically the same number that's there. So now I want grams, so I come up here by its mass. It has a mass of 20 grams is equal to a mole. So 0.442 at 20 gets me about 8.84 grams that I actually made. So 8.84 grams is what I actually made. Now in a perfect world, you're not wasting anything, and all you would have to do is, figure things out, but in reality, you might have ended up wasting things. Let's see. Oh, got into one more example here. All right, so based upon the equation below, how many grams of bromine can be made from that much silicon and that much bromine trifluoride, and how much of the excess reactant is left over? Okay, so I got 1.256 grams here, and I got 5.893 grams here. And I want to know how much of that is left over. All right, let's check it out here. This is my real world, and I need to get down here to moleville, but I'm going to have my have, I'm going to have my use, and I'm going to have my leftover that's there. All right, so I got to turn these guys into moles. We're just talking about grams for each of these guys. So let's see, that stuff weighs 60.1 grams. So 1.256 divided by the 60.1 gets me 0.0209 moles that I actually have of this. Bromine trifluoride is 3/19 for the fluorine and a 79.9 plus tax for the bromine. That stuff weighs 136.9 grams. So that at the 5.893 should be about 0.0430 moles that I have there. All right, so they're pretty close to each other, but it's a 4-to-3 ratio. I'm going to guess that the silicon dioxide is the one that I'm going to run out of first. It looks to me like I don't have enough of that, just by kind of guesstimating math in my head that's there. So if I try to use up all 0.0209 and be left with none of it, I have to double checkify that by a 4/3 ratio, because again, I'm going to 4 and I'm coming from 3. So 0.0209 times 4/3 is 0.0279, and I guessed correctly. So 0.0279. Again, had I picked the other one, and then I had gone back over to the sulfur dioxide, I would have ended up with too much, and it would have been a negative number down here in the leftover column. So even when you guess wrong, you get the right answer. You just might have to do a little bit more work. 0.0151 moles of that stuff that are left over, right? So it wants to know how much is left over. That's how much of the excess is left over. If it wants it in grams, then use the molar mass and turn it back to grams. All right, now I need to get over here to the bromine. I can choose either one of these guys. I can either go that way or I can go that way, as long as I am using the used column again. I've got to use the used, except that it's a row and not a column, and I talk a lot. Anyway, from there, that looks like a 2/4 ratio, and that looks like a 2/3 ratio. if I were to do it that way, because again, I'm going over here to a 2. So 0.0279 at a half, which would be 2/4, is 0.01395. Just double checkifying that the other one works out the same. And it does, 0.01393, 1395. That all depends on where you round. You're talking about, fractions of a gram at that point. And now I got to come up here. Hey, don't forget that bromine has a Br2, so that's going to be 159.8 grams is the same thing as a mole for that. 79.9 twice, 159.8. At the 0.01395 gets me about 2.22 grams. So that is all in all about 2.23 grams, depending on where you've rounded and all that kind of good stuff. So, limiting reagent problems. You are going to be presented with 2 different starting options. Only one of them is correct. And again, using my method, you figure out how much you have of each, pick one that you think is best, double check to see if it is correct, and then move on from there. There are lots of different ways to go about this process. If you find one that you like better, by all means, please employ it. I am not saying that I had the keys to the only way to do this. There's lots of different ways to do this. So if you find a better way to do it, by all means, go ahead, but this is the way that my brain